Today we're going to talk about composition of functions, and we're also going to talk about other operations, and this is really review, but if it's not review for you, let's dive in. Okay, so what are we going to be able to do after this lesson? We're going to be able to add, subtract, multiply, divide functions. We're going to be able to read function notation. That's super important. You should already know how to do that, but we're just going to reinforce it. And then we're going to compose functions, and we're going to know what all the symbols mean, and we're going to have examples of each. Now, when we look here, we start off with 3 functions, okay? And as you look through the examples, you'll see my h of x pop up. You'll see my g of x popping up all over the place. And you'll see my f of x popping up all over the place. And I really just want to show you that we're not doing it to we're not doing every function. We're just doing the ones that they actually talk about, right? So we have to like go shopping when the function notation it's telling you which function to go grab. Okay, let's talk the first example. So the function notation for adding, addition, it could either look like this or it could look like this. And so it's really important that you recognize that those are the same. So if I was going to do this problem, I would take my f of x to x plus 8, and I would add my g of x to x minus 3. Now, when I add those, when I have an addition sign between parentheses, I can just drop the parentheses, okay? So now we're just going to add like terms. So 2x and 2x will give me 4x, and 8 and negative 3 will give me 5. So this would be equal to 4x plus 5. Okay, let's see if I can make this a little neater next time, but okay. So the next one we're going to do is f of x minus g of x. So now we have 2x plus 8 minus 2x minus 3. So we're doing the same ones we did before except for subtraction. Well, now you guys, you can see how we don't have an addition sign between like we had before. We have subtraction. So we're going to have to add the opposite of everything in the guy that follows, okay? So we're going to go add the opposite of a positive and the opposite of a negative. So we're going to change those. And now we have an addition sign so we can drop the parentheses, right? Okay, here we go. And so this will give us, adding like terms, well, when we add a 2x and a negative 2x, we don't have any x. And when we add an 8 and a positive 3, we have an 11. So our answer to this one will just be 11. Okay. Remembering if we have a subtraction, we add the opposite. And maybe we'll put this right here. So add the opposite of g of x. So we would make everything in g of x the opposite. Okay, cool. So now we're going to talk multiplication. So when we're looking at multiplication, we see just this little closed dot right there, right? We have a little closed dot right there. So either one of these notations mean multiplication. And so all we would do is we would take whatever function they told us, so f of x, which is 2x plus 8, and then they told us h of x, which is x plus 4. And we're just going to multiply. Now, we know when we're multiplying binomials that we're going to be distributing. So we're going to get 2x squared plus 8x plus 8x. And then we're going to get 32. And after we add like terms, we're going to get 2x squared plus 16x plus 32, and that will be our product right there. Okay, multiplication. Now, division is kind of interesting because division, we're really just putting the functions on top of each other, and then we're going to see if there's anything in common, right? But we're always going to assume that whichever function we put on the bottom cannot be 0 because we cannot divide by a value of 0. Okay, so our f of x, which is on the top, is 2x plus 8. And our h of x, which is on the bottom, is x plus 4. So if there was nothing in common, we would stop here, but we need to see if we can factor. And on the top, we can see that both of these values have a 2 in them, so we'll factor out a 2, and we're going to be left with x plus 4. And on the bottom, I have x plus 4. Now, it's really important that when we have a plus or a minus, that we keep everything together unless we factor. So originally, we wouldn't have been able to do anything because our parentheses they were not exactly the same, right? But now they are exactly the same, so we can simplify and we'll just get a 2. Perfect. So sometimes there's really nothing to do except for stack them on top of each other. If you can't take a common factor out, then you're finished. Okay, composition. Let's really make sure we pay attention to this one because the difference between multiplication and composition is that this is an open circle, right? Open circle, closed circle, right? So that's the biggest difference. And so what this basically says is you're going to take your g of x and you're putting it into f of x. Now, how does that even make sense in your brain? Well, this is what it means. It means I have f of x. So I have the function f of x. And so let's just look at what the function f of x is. So f of x is 2x plus 8. Okay? And so every time I substitute something in, it just goes right into this spot, right? But if I'm putting g of x in, if I put 2x minus 3 into this machine, it's going to go right here. And then whatever comes out is going to be our new output. So what does f of x look like again? So f of x looks like 2x plus 8. And we're going to be putting g of x in. And g of x is 2x minus 3. And now we're just going to simplify this. So all we're going to be doing is simplifying this. So we distribute, and we get 4x minus 6. And then we add 8. And we're going to get 4x plus 2. And that's going to be what happens after we compose f and g. Now, order matters here, you guys. Order matters. So that's another thing that you need to make sure you remember, that it matters if the f comes first and then the g comes second, or vice versa, because we work this way. So first we do this and then we bring it into this, right? So we're going to be going from right to left. It's kind of like the most different thing that we do. Okay, so let's look at all of these. Now, as you look through here, the examples that we had above, we were just substituting an x in, right? We were dropping an x in, okay? So truthfully, if we looked at the model that we had before, we had the 2x minus 3 came out because our G machine was 2 something minus 3. This was our G machine, right? And we dropped an x in because G of x means all we're doing is putting an x in. And then out came the 2x minus 3, and then etc. Well, this one, we're going to be, you can do one of two things. You can find this and then substitute the 2 in, or you can substitute the 2 into each of them. So you can also do f of 2 minus h of 2. It really doesn't matter which one you do, and that's why this notation up here, it means the same thing, okay? So let's just do f minus h of 2. So f is 2x minus 8. So we have 2x minus 8 minus h, which is x plus 4. So first we're going to find, actually let's move this over. In this case, we are going to find f minus h of x first. Okay? And so we remember that we add the opposite. So we'll make this addition and make this opposite. And so we'll end up to have 2x minus 8 minus x minus 4. And after we simplify everything, it'll be f minus h of x is going to be x minus 12. Now, we didn't want it of x, we wanted of 2. So now we're just going to put the 2 in. Instead of putting an x in, we'll put a 2 in. And we'll get 2 minus 12, which is negative 10. So that's one way to do it, right? And let's do it the other way now. Let's just substitute the 2 in because I'm going to show you that it works. And so we have f of x is 2x minus 8. So f of 2 is 2 times 2 minus 8. So this is negative 4. And then we were talking about h of 2. So we know h of x is x plus 4. So h of 2 is 2 plus 4, which is 6. And then we wanted to take f of 2 minus h of 2. So this is f of 2, which is negative 4. And we're going to subtract h of 2, which is 6. And so you can see how we got negative 10 either way we did it. So it's totally your choice which way you want to do it. And that's with addition or subtraction. Actually, it's with any of these functions, right? It's totally up to you. I'm going to do the next one. I'm going to do this g of 3 times h of 3. So for g of 3, we go up to the g function, which is 2x minus 3, 2 times 3 minus 3, and we're going to get 6 minus 3, which is 3. Now we're going to go to h of 3. We go to the h function, that is x plus 4. So we're going to go 3 plus 4, because we're substituting a 3 in for x, and so that will be 7. And we wanted to do g of 3 times h of 3. So this is 3 times 7, which is 21. And I'm not going to show you that it works both ways. It's up to you if you would like to look at it the other way. Now, the next one, you're going to see that instead of dropping an x in our interior function, we're going to drop a negative 3 into h first. So let's see what happens when we take a negative 3 and we put it into our function h. H is x plus 4. Oops. Sorry about that. So this is negative 3 plus 4, which is just 1. So now this part right here is going to be replaced with a 1. So now I have f of 1. And now I'm going to go to the f function, which is 2x plus 8. And I'm going to go 2 times 1 plus 8. So this is 2 plus 8, which is 10. So first we took the negative 3 and put it into the h, had the output come out of 1, and then we put that output into f. So if you want to look at it visually, it would have looked like first we went into h, and then the output fell out and went into f. So we put a negative 3 in, out came a 1, the 1 went in, and out came a 10. And so when negative 3 goes into the competition, out comes a negative 10. But you guys don't have to write the function machines if you don't want to, but if it's helpful, go right ahead. Now we're going to look at this a little bit differently. We are going to now put basically a number in front of our function, which means we're going to be multiplying it by a scalar, or scalar multiplication. So this says 2 times f of x. Now I didn't put anything in, just x, so my f of x is 2x plus 8. 2x plus 8. And then I'm going to subtract 3 times g of x, and our g of x is 2x minus 3. 2x minus 3. Okay, so here's the deal, you guys. We're going to multiply these out first. So you're going to take a 2 and take it all the way through here to get 4x plus 16. And then you're going to be taking a negative 3 all the way through here. And you're going to get negative 6x plus 9. Okay? And now you're going to simplify this. So this is going to be negative 2x plus 25, and you're finished. So you can see how there's different parts, right? And then we're going to do one more composition because I think that it's important to see the difference between this notation and this notation. But remember that they are the same, right? They are the same. This still means h of g of negative 2, which means negative 2 went into g, and then we took whatever came out and put it into h. So let's first look at what happens when we put a negative 2 into g. So we go up to g, 2x minus 3. So we're going to go 2, and then our x is now negative 2. Oh, what did I just say it was? 2x minus 3. I've already said this 3 times, so I don't know why. And then negative 4 minus 3 is negative 7. Okay, now that's what's going to be going into h. So now we're replacing h of negative 2 with negative 7. And now the negative 7 is going into h. And h is x plus 4. So we're going to go x, which is now negative 7, plus 4. And so we'll end up to get a negative 3. So this whole thing is equal to negative 3. And it's really important that you realize that you're not multiplying by negative 2. You're substituting a negative 2 into g and then taking whatever comes out and putting it into h. Okay. So hopefully this is helpful, you guys. I'm hoping that this rings a bell for you. And I know that I was going up and down in this notes all the time, and I'm really sorry, but have a wonderful day, you guys.